Hello. This video will demonstrate how to find limits of simple rational functions and polynomials as x approaches infinity. So far, we've talked about what's the limit as x approaches 2, or as x approaches 1, or as x approaches 0. And remember, we have to make sure that we come from the left and the right of that value. But what if we just let x go to infinity? What will be the behavior of the graph? So we're first going to look at a graph in a rational function where I have 1 over x, or 1 over x squared, or so on. Okay? And again, I want you to think about this. Excuse me, let's change that mode. All right, suppose I have a point and I want to say, okay, what does the graph do as x just keeps going to infinity, to infinity, to infinity, to infinity? Now obviously this is not infinity, right? But as x just keeps getting larger and larger and larger, right? What happens to this function as x just keeps bigger and bigger and bigger? It seems that y, the y value, has reached some lower limit. All right, it doesn't seem like it's going to go below 0. Okay, again, as I go to negative infinity, it looks like it is also, the value of the function seems to be approaching 0. All right, so again, remember when we talk about limit, we're talking about where does the graph go? What is the behavior of the function as x does its thing? In this case, moves toward infinity. Here's another example. I have 5 over x cubed, all right? And again, as x approaches infinity, what does the graph do? Again, it looks like it seems the behavior of the graph, it's going to y equals 0. It doesn't seem to reach y equals 0. And again, going to negative infinity, it also seems like the function goes to 0. And let's look at one more, 4 over x to the 8th. Again, it looks as if as x just keeps going to infinity and forever in the right direction, the behavior of the graph approaches 0. Y approaches 0. And same thing as I go to negative infinity. So to generalize, we can say, something that's a little funny. So we can say that as x approaches infinity, the limit of a function that looks like this, where we have some constant divided by x to raise to some exponent. Again, the exponent could be a fraction, right? It doesn't have to be an integer as we have seen. It will approach 0, all right? And we could add plus or minus because we saw that if it approached positive infinity or negative infinity, all right, it's going to be 0. All right? Just be careful about this type of function where if we do have a fraction exponent, remember, this really means, right, the square root of x cubed. And remember, because it's square root, this cannot be negative, so I can't really go to negative infinity in this case. So again, just be thoughtful. Always keep in mind the function that you have. So let's look at some polynomial functions. In this case, we see that our degree is 4, and our leading coefficient is 1, which is positive. So as x gets really large, right, as x gets really, really, really large, it looks like the function just keeps going up and up and up and up and up and up, right? And that will go, so as x gets huge, the y value gets also huge in the positive direction. So the limit would be positive infinity. Similarly, as x goes to negative infinity, the function seems to also get larger and larger and larger and larger. Okay? So again, in this case, as x gets really big, right, the function also gets really big in the positive direction. So right, if x goes to positive infinity, it looks like the function's going to positive infinity. As x goes to negative infinity, it looks like the function's going to still positive infinity. Okay, let's look at another example. So, as you can see here, my degree is 6, so it's an even degree. My leading coefficient is negative. In this case, again, as x gets large, the function gets infinitely small. It goes to negative infinity, correct? And I'm hoping you see as x gets really goes to negative infinity, so does the graph. It goes to negative infinity. Notice the difference when I'm saying the infinities, right? When I say x going to infinity, I'm talking about this motion. To say that the limit is negative infinity, that's saying where does the graph go? The graph goes to negative infinity. So you have to be very thoughtful about what we mean by limit. As x goes somewhere, what does y do? Let's look at another example. In this case, we see that our degree is odd. Our degree is 3, and our leading coefficient is 2. Again, you should know the general shapes of polynomials. Again, as you can see, as x gets extremely large, goes to positive infinity, the graph seems to go to positive infinity on the y. Conversely, as x approaches negative infinity, looks like the graph goes also to negative infinity on the y. All right? Let's see what happens when my degree is still odd, but my leading coefficient is negative. As you've surmised, I hope, right? As x gets really big, y gets really small. So again, as x approaches infinity, the function approaches negative infinity. As x approaches negative infinity, the function approaches positive infinity. All right? Again, you have some graphing programs. Play around with these or watch this again. So it needs really to make sense to you. In general, right, when our degree was even, doesn't matter if we went to positive or negative infinity, if the leading coefficient was positive, the function will always go positive. If the leading coefficient is negative, then the limit, whether we go to positive infinity or negative infinity, as x approaches either one of those, the function will approach negative infinity. And what happens if our degree is odd? If the leading coefficient is positive, we just saw that the function will approach positive infinity. Conversely, if x is going to negative infinity, the function will approach negative infinity. Again, the opposite is true when the leading coefficient is negative. All right? Again, I know it seems like a lot to take in. If you know the shapes of your graphs, okay, you can just draw a quick sketch to see what happens. All right? It's not that bad. Well, I hope this helps. Thanks for watching.